was working an 11-hour shift. No, you were not. That's false. You were working your shift plus somebody else's shift. Don't you work at Chick-fil-A? Mm-hmm. Yeah, see, you were not working an 11-hour shift. You were working 2 shifts.
Well, no, they scheduled me for 10 today.
What?
I work for 9 hours.
Full of crap. Oh. Okay. Geometry. Circles. Like I told you, girl, timing. That doesn't even work in that context. You have to.
No, it doesn't. I just wanted to say.
So I feel like you've answered your own question when you were like, why is when I make your face jokes not funny or your mom jokes not funny? That's why.
That wasn't
Yes.
a joke.
I need to take the chapter 9 test.
You do. Let's see if I have a copy of it. I did the other day. Let's see if I still do. Chapter 9.
I don't drink coffee. I'm not fan of Coffee Kings. But then I drink a thing on Monster and 600 milligrams.
That's too much.
People that brag about their energy drink consumption always crack me up. It's just kind of a silly, brag.
I can drink black coffee, but I swear, energy drinks has battery acid. I cannot.
All right.
This face looks like a battery acid. Thank you, honey. Love you too.
We're on 10-2. Or did we do 10-1 and 10-2? What did we? Yeah, that's right. On 10-1, we did
2, 4, 6, 8, 9.
Oh yeah, 2 through 8 and 9. All right, so on 10-1, we did number 2A is EF and DF. Number 2B is DF, segment DF. Number 2C is segment NC, segment ND, segment NE, or segment NF. Number 4 is 26 feet. Number 6 is 5 inches. Number 8 is 17.98 feet and 8.99 feet. 9 is 4 pi times the square root of 3. Yeah, 4 pi times the square root of 3. What questions do we have on those before we do the next one? Number 9. Did you try it?
Yeah.
Where? No, I see. You wrote you wrote some formulas. Okay, I guess. Didn't I leave that bowl in here? Yes, I did. Bowl. Time for a bowl cut. One of those, no.
I got a question on number 6. You said the answer was 5, right?
On number 6, I said the answer was 5. Let me see. 5 inches, yeah.
Oh, I was reading the question wrong. It said diameter, not radius.
Well, there you go. Reading's hard.
Reading is easy. Reading comprehension is hard.
8 centimeters and 12 centimeters. And the right triangle shows inscribed in circle D, which tells us that D is the center, right? Find the exact circumference of circle D. So what formula do we need to know? That was an open question to the room.
We don't have a theorem.
Probably Pythagorean theorem. What else are we going to need? Circumference. So what's the formula for circumference?
Pi times the diameter.
And Pythagorean theorem is a squared plus b squared equals c squared, right? What is c in this problem? The hypotenuse, which is what here?
The
Diameter, right? So, c squared equals 8 squared plus 12 squared. What's 8 squared? 64. What is 12 squared?
144.
What's 64 plus 144?
208.
And then we take the square root of both sides. C equals, we need to reduce square root of 208. What perfect square goes into 208?
The bigger number or the little number?
Always a bigger one if you know it. If you can always start with a smaller one and then go further. But okay, so the square root of 16 times the square root of what? 13. Okay. So that equals 4 times the square root of 13. To find circumference, we multiply that diameter times pi. So the answer is 4 pi times the square root of 13 centimeters. Any other questions on that lesson? Okay, let's look at the next lesson. We did 14 through 36 maybe? 42, great. 14 is 80, 16 is 35. 18, the minor arc is 55 degrees. Number 20 is a semicircle, it's 180 degrees. Number 22 is a major arc and it's 325 degrees. Number 24 is a minor arc and is 55 degrees. Number 26A is 273.6 and 14.4. 26B is a major arc and a minor arc. 26C is yes, because the arcs associated with the online and none of these categories have the same arc measures, since each category accounts for the same percentage of the circle, 9%. 28 is 40 degrees, 30 is 180 degrees, 32 is 320 degrees, 34 is 100 degrees, and 36 is 260 degrees. Excuse me. 38 is 4.54 inches, 40 is 4.75 millimeters, 42 is 19.1 feet. So, what questions do we have from that lesson? 40. Nice. Is that the only one you didn't use photo math on? That's sorry. But kind of funny.
Oh, definitely funny. I guess I just had that face that people just like to make the...
Well, it was Pick on Gina Day last class, so I guess it's now Pick on Helen Day.
That was great. We should do that again.
We probably should. You felt very loved. Yeah, that's good.
I love to insult my friends. They're not good insults, but they are insults.
Was it a songwriting competition?
I don't feel like imaginary people get insulted very often.
Well, Helen, do you insult your friends?
Yeah, which is
Then
why I don't
imaginary people
insult
do it.
any of y'all very well, because, you know.
Jacob, You're about to turn it on to pick on Jacob Day because that was
Yeah.
really crappy.
Yeah.
That was really stupid.
It was just a little late.
It was a little late and like
It
a repeat of the same joke,
Yeah.
but
It had
worse.
potential.
Yeah, I know. I did. I said the potential one. I used its potential to make a joke. 40.
Those who can't do, copy those who can.
It's okay. We can all do good things in the world. Like whenever you die, you can donate your face to science so that they can find a cure for it.
You know, I feel like that would have been funny if you didn't copy that from somewhere else.
Yeah. Yeah.
That was clearly a like I'm quoting something from something else. It's funny. It's just wasn't your joke.
Yeah. Most of the jokes I say are online, actually.
You gotta practice telling it like it is your joke. You gotta like have your own vibe to it. That's what you got to do. Circle P.
You gotta sound a little less like you know what you're doing.
Right?
Then it's more helpful.
Out of all the questions, 38 through 42, I had to do it assuming that RT was a diameter.
Yeah.
Is that what we're supposed to do?
I assume so.
Oh,
Because there's no other way to do it. But yeah, we've had that issue in the book before. Sometimes like, okay, yeah, you wrote a bad geometry problem because you really needed to say that this was this, or else there's no way we can even solve it. So number 40 says we want to find the measure of arc Q something R if the measure of P S equals 4 millimeters. So P S is 4 millimeters. And we're given, let's see, 130 degrees and 112 degrees. And yeah, that's it. So this is 4 millimeters and we are looking for QR. So this one right here. So if we assume that RT is a diameter, which again, we kind of have to in order to be able to solve this problem, which they should have put that in the instructions, but they didn't. But we'll assume that that's true. What can we do?
find the measure of angle QPR.
Find the measure of angle QPR. That's great. So this angle right here. How can we find it? 180 minus 112, which is 68 degrees. Now what?
The length of the arc over the circumference equals 68 over 360.
The measure of QR over what? Circumference equals 68 over 360. So we need to find the circumference of the circle. We don't have that yet, right? We have a radius of 4 millimeters, right? So the circumference would equal 2 times pi times the radius. So 8 times pi, which is what?
25.13.
3 millimeters. Okay, so the measure of QR over 25.13 equals 68 over 360. What do we do now? cross multiply. So what is 68? So I've explained this several times, and it bears saying again, you would have this number in your calculator. So you just push times 68, right? That way we keep all those decimals until the end. Don't round until the very end. So we've got 360 times the measure of QR equals whatever that equals. What does that equal?
1709.03.
Okay, so again, you'd have that in your calculator and you just put divide by 360, right? So the measure of QR is approximately equal to what? 4.75. Here's hundredths. 4.75 millimeters. Easy money. Okay. Any other questions from this lesson?
We do 26A.
26A. What would be the arc measures associated with the mall and vintage stores categories? So let's see. Oh, the arc measures. Yeah. So the mall is 76% of the total. So we need to find 76% of what? 360. Which equals what?
273.6.
273.6 degrees. Mall. And then the other one's 9% probably, right? Yeah, so you do 9%. So 0.09.
It's 4%.
Is it? Oh yeah, you're right. 0.4. Well, my 9 was ugly enough that it might have been a 4. Who knows? And you get 14.4 degrees. Make sense? Good. All right, let's do 10.3 times it. Yeah, great. Your PayPal verification code. All right. This Friday, I'm selling stuff. Y'all should come check it out.
You're what?
I'm selling stuff not Friday, Saturday. Y'all should come check it out.
Where?
At Connect Church.
What stuff?
Well, there's going to be some fabric stuff and some wooden stuff. There's going to be some scrunchies and headbands and bags and keychains and cup holder things and coasters and maybe some planter boxes. It is the price of handcrafted goods. So it depends on what you mean by expensive.
Well, because I'm broke, so that's why I buy everything.
We are all children with little to no disposable income.
Well, yeah, bring your parents and be like, Mom, look, this is awesome. I need
How
it.
much this entire outfit cost?
Be like, Mom, look, I am going to drive. I need a cool keychain.
I'm going to bring my equally broke college friends, and none of us will be able to afford
Well,
it.
there you go. Maybe you put your pennies together and y'all can buy a scrunchie.
Please,
All right. Arcs and chords. We got some more formulas to learn. Some theorems and some formulas, which probably means proofs, right? Yay. All right. Theorem. Okay. In the same circle. I started writing theorem. But I wanted to write in the same circle. In the beginning. In the same circle. Or in congruent circles. Two minor arcs are congruent if and only if their corresponding chords are congruent. So, in pictures, we're going to do our best effort to kind of draw a couple of congruent chords. Something like that-ish. What? Okay, thank you. So, in symbols and pictures, what this theorem says is it says that arc FG is congruent to arc AB if and only if segment FG is congruent to segment AB. So you can see from this theorem and its converse, because the converse would also be true, the chords are congruent if and only if the minor arcs are congruent, right? So, excuse me, we could use this to prove a couple of minor arcs are congruent, a couple of chords are congruent, all of those kind of things, right? That's where we would use this. We'd also use it mathematically to start setting things equal and solving for x, right? Making sense so far? Any questions so far? This one is simple enough, it's almost postulate level simple, right? It's not very complicated. The chords are congruent, then their arcs are congruent, right? That's essentially what we're saying. All right, here's a couple more theorems. I'm going to leave my circle up, but draw some different pictures. So y'all get your little Stanley cup out and draw you a couple more circles on your page.
Why do people even like Stanley Cup?
I honestly have no idea. Same reason Timberland boots became popular. I don't know. Some fashionista weirdo in New York was like, oh my gosh, we could make these work boots cool. Or, oh my gosh, we could make this work brand cool. And then everybody else did it.
They went from the old Geico company to
Jen
the
Alpha
middle
would be
pedestrian.
I know. Same, like I say, same with Timberland boots. Like, why is this a thing? I don't know.
I'm so scared of Jen Alpha.
Oh my gosh. Quit watching the internet. They're babies. Don't be afraid of them. They're not going to be...
I'm not talking about now. But
They're not going to be any more stupid than y'all are. It's fine. Y'all aren't any more stupid than we were. Same difference. It's fine. Same difference.
You don't need to be scared yet, because you can just like drop kick them, because they're like 3.
I'm not saying I'm scared of them now. I feel like I'm gonna be scared of them when they get to Gen 19.
You know what's going to be hilarious is when y'all get old enough to be like, oh my gosh, kids these days. And then you'll be like, oh, now I understand.
Oh my gosh, kids these days are in virtual reality too long.
The amount of pain that my dad felt when he Googled Stanley Cup and the first thing that came up was not the hockey trophy. He was so sad.
That's funny.
I was like, yeah, I was explaining to him what the Stanley Cup was, and he was like, Gina, if I Google Stanley Cup, you know what's gonna come up. And I was like, I know what you want it to be. I know what you want it to be, but I know what it's actually gonna show up as. And then he was like, I had to scroll to find the trophy.
That's
I'm
crazy.
so sorry.
All right, so there's some pictures. We're going to write 2 theorems about these pictures, and then we're going to write it in words. All right, so if a diameter telling you.
Circle, so.
Yeah, I mean, it's.
Pull out your little cup. If a diameter or radius
911 is just a number.
It is, until you put it in context of the phone number.
of a circle
Probably what you keep in your contacts.
I mean,
I mean, technically everybody does, because if you try and turn your phone off, it tries to call the police.
is perpendicular.
You hold on the buttons and then there's the emergency SOS.
Oh, yeah.
To a cord.
That was not it.
Okay, guys, shut up, please. We're rude level at this point. If a diameter or radius of a circle is perpendicular to a chord, then it bisects its, excuse me, the chord and its arc. Okay, so this is circle C. What does that tell us? Like just writing, this is circle C.
That AC/CD is the radius of the circle.
Right, C is the center, so AB is the diameter, right? AC is all the things, right? Great, so what does this theorem tell us if I was to start marking up my picture? Let me give another letter so we can talk about what we're doing. Let's call this D, how about?
That YD and XD are congruent.
Right, so these two are congruent. Also, these arcs are congruent, right? There's something I didn't draw on my page that I really need to draw in order for this to match this.
The right angle.
Yeah, we gotta say that this is a perpendicular angle. These are perpendicular, yes? Great. So, second theorem we can say about this picture. The perpendicular bisector of a chord is a diameter or radius of the circle. So that is essentially the converse of the other, right? So if we can prove that this line here, the line AB or line AC, whatever we want to call it, is a perpendicular bisector of XY, then we know for sure it's a diameter, right? That's or radius if we're talking about like just CB. That is what this one says. Let's do a math problem, a mathy looking problem, then let's do another theorem and another mathy looking problem. I really want to chuck in a proof in today's lesson if we have time. Yeah, we'll jump over and do like 25 or something if we have time, which we may. We'll see.
Question.
I'm listening.
On number 17 of the problem set, it shows a circle like this, except then it asks for the measure of what on yours would be DB.
What is your question?
How do you find that?
Well, let me get to some
This
examples.
is that one that we're going to.
Let's see what happens, and then ask that. And then if I still haven't answered your question, then ask. Okay.
Where's the staple?
It's up there. Just set it on my table. That's fine. I'll staple it here a little bit. All right. Let's do this problem. That one's too easy. Let's do this one. Let's make a circle. Imagine that.
I, for one, am shocked.
Who'da thunk it? Great, there he is. He has a tumor, but he's there. Okay.
Nobody's perfect.
Nobody's perfect. We got this, and we got this. And we've got 5 and 6, and this is point S, and this is perpendicular, and this is T, and V, and U. And we've got circle R, and we want to find the measure of TV. All right? So, what do we know about this? What things do we know about this circle? What is RU? Let me throw you a bone. It's a radius. We know that because of the theorems we just talked about, right?
And we know that TS and VS are congruent.
Yeah, we know that's true. That's true. We know that this is good to this. We know that UR is a radius. Nice. And we're looking for TV. So we're looking at this total. So if we could find one of them, then we could just double it, right? Because they're congruent.
We know that TV is a diameter.
We know that TV is not a diameter.
I meant
U and whatever point this would be over here.
diameter is 22 is what I meant. But
Oh.
you said TV is
Yeah. What if we do this? That orange dotted line that I just drew is a what?
radius.
It's a radius. How long is the radius? 11. So this is 11. So now, how could we find this one?
11 squared minus 6 squared equals SV squared.
In other words, you're using the Pythagorean theorem, right? Right. Yeah. So, we could say that the measure of SV squared plus 6 squared equals 11 squared. What is 6 squared?
36.
What's 11 squared? 121. And then we could subtract 36 from both sides, right? So the measure of SV squared equals, what's 121 minus 36? What? 85. Then we could square root both sides, right, to get rid of that squared. We end up with the measure of SV is approximately equal to 9 point something. 9.22. So now that we have this one, we just multiply that times 2, and we have the measure of TV equals, is approximately equal to, we should say, 18.44. Let's get another theorem up in here. I didn't mean to say that weird, but it just came out that way. It's another theorem about circles. That's crazy, bro. Y'all want to know something that is crazy? I've been watching lots of videos about making bags and stuff because I've been making bags. I've been watching different people's ideas and whatever else and all of those things. And this one lady was using geometry to show how to make the bottom of your box bottom bags not droopy and ugly. And it's like obvious geometry stuff that y'all would be like, oh yeah, I understand that. Yeah, I know. That is the wild thing about Gen Z to me. Is Gen Z, by and large, as a group, don't have any interest in making anything.
Making?
Yes.
I would disagree with you.
By and large, the majority, I will tell you right now, because most of the times I show Gen Z people as a group, as a large group, something, they're like, oh my gosh, why would you spend all that time to make that thing? That's the number one response I get. There are definitely exceptions. And maybe now that y'all are getting older, y'all are starting to get into your making phase. That's possible. That would be good.
Most of the people my age that I know have a thing.
Have a thing.
Have a thing that they do, that they make, that they have. They
I wrote 11
do, and that's not just homeschoolers either. Like, I would like to point out that is not just people who are homeschooled.
I have written 11 books. So
What kind of things are we talking about?
I mean, I know a lot of people with Etsy shops. I know people that just do craft things because they want to.
Etsy is garbage.
Etsy is garbage, but it's not.
We need a replacement.
Money. It's because they're doing the thing that they love. And
Well,
they
that's
know
good.
It's not sustainable. Like they're like, I'm not.
Of course, you are you, so you might have friends that would tend to be in that group.
No, and that's a great point. But like, I mean, I have a friend who custom paints shoes and makes like thousands of dollars with them.
Nice.
Like,
So cool.
but yeah, it's phenomenal.
In the same circle.
I'm like the makiest person out there.
Proof? Didn't you make your bag?
Or in congruent circles.
It's falling apart, so it must not be that.
All fabric goods fall apart eventually. Even fancy schmancy wax canvas and leather bag is eventually going to fall apart. In the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. All right, so we can see all kinds of applications for this. We want two congruent chords anywhere in the circle. All we have to do is have two chords that are equally distant from the center. So if this is equally distant, then the measure of FG, ooh, that's a weird looking G. Don't know what happened there. FG equals the measure of JH, right? Or they're congruent. If and only if these are congruent. Okay? Let's do a problem with that. Did you say, oh no?
No.
Oh.
Is there a Wirecast theme song?
No, because it's a book, not a TV show.
Oh.
For now.
How
It would not make a
Victor
good
Wreck
TV
said.
show. It would not make a good.
Well, according to you, it doesn't make any even good books.
It doesn't. Which is why it bothers me so much when people say I'm a Warrior Cats kid, because it's a
You have brought this upon yourself.
Poor baby.
Then again, I do like My Pride, which is basically the same thing.
My Pride, is that what you said? Yeah, same thing, but with lions.
Or is it lions?
Yes.
Okay.
Wow.
Well, there you
She's
go.
so different, you guys.
I read about different cats.
She's not like other girls at all.
That's funny.
Wait, I bet you wore Converse to prom, didn't you? That is so different.
I didn't go to prom.
I know you didn't. You're lame.
I know. I didn't go on purpose.
Mm.
That's crazy.
I wanted to go so bad.
Mm.
I rented a suit and bought a ticket.
All right, so we've got circle H. The measure of PQ equals 3x minus 4. And the measure of RS equals 14. We want to find x, and x is somewhere. Where is x? Oh, right there. Find x. So, what should we do?
Add 4 to 14.
I think we should label the picture first. Right? We don't even have to add 4. We don't even have an equation, bruh. Calm down. PQ, this one right here, is 3x minus 4. RS is 14. What do we know about segment QP and segment RS? We know they're congruent. How do we know they're congruent?
Because the radiuses that are perpendicular to
They're not radiuses, but yes.
the lines perpendicular to the
Yeah.
Hard to do it.
They're equidistant from the center. So yes, we can set up 3x minus 4 equals 14. And then yes, we would in fact add 4 to both sides and end up with 3x equals 18. And then we would divide by 3 and get x equals 6. Easy money. Right?
Money is not easy to get, I'm afraid.
Yeah, it is. Money is easy to make. All you have to do is find a good or a service that somebody else needs and or wants and do that.
But you gotta get skill, and that's not something that I have.
You have skill, you made that bag.
That is true.
Money is hard to get because it requires work and effort and talking to people.
Who wants to work for things?
That's like the most Gen Alpha sentence I ever heard in my life. Or Gen Z.
Most people on Earth want to work towards a goal.
Yeah. Not if you listen to the crazy people.
I work so hard on things that I want to, like things I want to make, and then when it comes to like doing stuff I should actually do, it's like,
Well, if you want to find a career that you love, find where those two things overlap.
that's good advice.
And then also,
Also, make smaller goals. Figure out something you can do today and do that one little thing.
straight up.
That's not possible for me. When I want to do something, I'm going all out.
Well, yeah, no, you're not understanding. I'm saying doing the things that you don't want to do, the way to get to do those is to make smaller goals. Break it up into smaller pieces and do this, because this thing, I can't do this right now. It's too scary or too boring or too stupid or too painful. But I could do this one thing that moves me a millimeter closer, and then do another millimeter, and then another millimeter, and eventually you get there.
Like when I do a test, I can write my name and it'll just be done.
Well,
No,
like
see,
if I
you-
want to be a manager at work, if I want to be promoted at work,
Yeah.
I'm too scared to just go up to them and ask, hey, promote me. But instead, today while I'm at work, I could do things that they know.
That's kind of a skill issue.
Like different. Like, oh,
You're refusing to understand the point. It's okay.
No, I understand the point.
All right, kids, goodbye. There's your homework. Have a nice life. I'll see you on Thursday.
It's too late.
It's too early. Thursday comes in 2 days.